Strip away the sentimentality, and a household is, at its core, a complex micro-social system. Like any organized system, it requires a clear structure of governance to survive. When we zoom deeply into the hidden machinery of this specific environment, we reveal a highly demanding, multi-layered daily operation. Running this system requires relentless daily decision-making, precise long-term resource allocation, and a reliable mechanism for internal conflict resolution. Every single day, the operators must process strict financial budgets, tight logistical scheduling, continuous crisis management, and competing career priorities. The prevailing modern assumption is that a system like this achieves maximum stability through absolute structural equality, enforcing a strict standard of 100% role parity between its operators. However, systems theory dictates the exact opposite. Enforcing identical roles ignores natural functional efficiencies and introduces a fatal structural ambiguity into the architecture. Removing distinct role boundaries does not eliminate friction between two people. It simply deletes the rules of engagement, guaranteeing that the system will break down over time. This breakdown begins with a mechanical flaw known as role conflict. It is the inevitable byproduct of demanding identical functions from two different entities. This split-screen diagram compares the mechanical efficiency of parity against a complementary structure. The model on the left prioritizes ideological symmetry over mechanical logic. By forcing identical sizing and placement, the gears immediately grind against each other, creating constant friction. The complementary model on the right utilizes differing capacities and dimensions. Because the shapes do not compete for the exact same space, they efficiently transfer energy and maintain forward momentum. Returning to the parity model, that physical friction translates into systemic ambiguity. When two operators occupy the exact same role, neither entity knows who holds the ultimate responsibility for a task's completion. Forcing parity into the equation paralyzes the system's ability to coordinate. To isolate exactly where these operational bottlenecks occur, we can map relationship structures using network topology. This network maps the parity model. Nodes A and B possess perfectly overlapping spheres of responsibility. A data packet enters, finding no clear processing hierarchy. It bounces chaotically between the two nodes. Where these conflicting paths stall, role conflict erupts. In structural terms, this specific failure state is defined as the dual authority trap. The mechanics are straightforward. When two entities possess identical claims to leadership, but the system lacks an established tie-breaking mechanism, decision-making completely halts. Under dual authority, a minor disagreement over scheduling or budget mathematically escalates into complete structural gridlock. This gridlock is generated entirely by the undefined structure itself. It occurs independently of the personality, stubbornness, or intentions of the individuals involved. The dual authority model is inherently unstable. It lacks a designated conflict resolution pathway. An alternative to this gridlock is shifting structural dominance entirely away from historical norms, elevating the female node to the primary leadership position. As the network topology shifts to elevate node B, visual stress indicators immediately appear. The foundational struts connecting the system begin fracturing under the load. This arrangement introduces a systemic mismatch between the overarching structural load and natural functional capacities. Applying an artificial framework over underlying natural tendencies fails to stabilize the system. The physical equivalent of this structural misalignment is an archway built with an inverted keystone. The uneven weight distribution forces the supporting pillars to buckle. Dominance inversion actually exacerbates the dual authority trap. The system remains in a constant state of tension, fighting to reestablish a natural equilibrium. Artificial dominance inversion increases systemic friction because it subverts complementary mechanics rather than utilizing them. The highly optimized solution to this friction is the complementary architecture. The nodes reorganize. Node A, the male role, sits atop as the central routing node. Node B, the female role, operates as an essential parallel processing node. Data flows continuously from B to A. As Node A executes decisions, role conflict flashpoints disappear entirely. This model operates on the principle of functional asymmetry. Stability is achieved precisely because the parties have distinct, non-overlapping primary domains. Node B provides vital input, counsel, and complementary data processing. This constant stream of information critically shapes the final execution. The distinct male leadership role of Node A operates strictly as an essential structural mechanism. It is defined by accountability, entirely separated from arbitrary dominance. By designating Node A as the definitive tiebreaker, the architecture mathematically eliminates the dual authority trap. This generates immediate operational benefits. Rapid conflict resolution, provides clear direction, reduced daily friction, and highly streamlined resource allocation. This specific hierarchical design guarantees a final point of accountability, coordinating long-term stability without relying on coercion. When we zoom out from daily decision-making, we can analyze how these structural models perform over the span of decades. This chart maps systemic stability over time. The x-axis tracks performance across decades. The flat parity model line traces a highly volatile, erratic wave that consistently turns downward. In contrast, the complementary model plots a smooth, consistent upward stabilization curve. The parity line degrades because unmanaged minor conflicts steadily accumulate over time, slowly eating away at the system's baseline trust and operational efficiency. The data reveals a clear finding. Long-term operational effectiveness stems from clear roles and tight coordination, not identical structural positioning. A functional, male-led patriarchal system operates by integrating mutually complementary contributions. Like an antique clockwork mechanism, the parts are vastly different in shape and size, but they are engineered to work flawlessly in unison. The clinical reality of this model is that successful execution relies entirely on duty, clarity, and assumed responsibility. It strictly rejects unilateral suppression. When evaluated purely on the metrics of reducing systemic conflict and increasing operational efficiency, a clearly defined complementary male-led structure decisively outperforms any model that attempts to erase functional differences.